Here's another rate times time equals distance problem. Reggie made a business trip of 251 miles. That's going to be the total distance. He averaged 55 miles per hour for the first part, 47 for the second part of the trip. The trip took a total of 5 hours, so this is total. These are some totals here. How long did he travel at each rate? Okay, so let's start with rate times time equals distance. Let's also make sure we're clear on our units here. Rate is in terms of miles per hour. Time, we're talking about hours here. And the distance is in terms of miles. We've got the first part of the trip and the second part of the trip. Okay, the first part of the trip, he averaged 55 miles per hour, and the second part was 47 miles per hour. And now the time that he took for each of the parts, that we don't know. So let's let X be the time that he took for the first part of the trip, and Y be the time that he took for the second part of the trip. We can even write that down over here. Like let X be the time in hours for the first part, and Y be the time in hours for the second part of the trip. All right, so now filling out this chart, we always typically go rate times time to get our distance. So that's going to be 55x and 47y. And then, excuse me, since we have some totals here, let's let those dictate what our equations are. He made a business trip of 251 miles. So he's got the first part distance, second part distance. The total distance should add up to 251. So first distance plus second distance equals total distance. Also, the trip took 5 hours. So here we have the amount of time that the first part of the trip took, and here Y is the amount of time the second part of the trip took. So if I add those together, it should have taken 5 miles altogether. All right, so here's my system of equations. You can use whatever method you like to solve them. Because this second equation is really easy to isolate one of the variables, I think I'll just use substitution. Let me subtract y from both sides to get x equals negative y plus 5. And then I'll substitute. I'll substitute this negative y plus 5. If x is the same as negative y plus 5, let's plug that back into this first equation. I'm going to replace the variable x with the quantity negative y plus 5. I'll do that over here. 55 times, instead of x, I'm going to write negative y plus 5 plus 47y equals 251. Now I just have one variable which I can solve for. Let's go ahead and multiply. Negative 55y plus, what's 55 times 5? 25, 27, 275 plus 47y equals 251. All right, now I'm going to combine my like terms by doing negative 55 plus 47, which will give me a negative 8. So these two guys together gives me a negative 8y plus 275 equals 251. Then I'll subtract 275 from both sides. I get, on the left-hand side, negative 8y equals a negative 24. I'm checking my work. Yep, and then divide both sides by negative 8. You get y equals 3. Okay, so now you should be really happy that you have an answer for y. And now let's go back to the question. Question is, how long did he travel at each rate? So y equals 3. That's 3 hours. So what is x? Well, if we go back to this first equation, x plus y equals 5, we can plug in 3 for y and see that x has to be equal to 2. Now I should write down my answer. He traveled 2 hours for the first part and 3 hours for the second part. Okay.